Hello? Oh, this was a hassle to say the least to start. Took me took me a couple hours actually to get this whole thing started. So let me get some things configured so so you guys can see me well. The very much needed water and and the light, which will help. All right, so I have a chat set up somewhat on the side. I think I don't know where my camera is. Right here is a chat. Maybe I'll put it like right there. Actually, let me see if I can do that still. Okay, nope, wrong thing. Oh, perfect. Kind of better. All right, so I have my table here. You guys are like 90 degrees faced. You guys are like this way. It doesn't matter. Your camera's up here anyway. All right. All right. So this was a high school project I did for a class, an AP class. Now this project was for physics, psychology, and I was making a brain thing, kinda. It was like a brain thing, I guess. It was like talking to the brain. So this was a couple of years ago, actually. This was two and a half years ago. Which, I say 2.5 years ago like it was such a long time, but I mean it kind of was, because now stuff, can't remember some things. So, I forgot how much of a pain this was to make, because I have everything labeled, like 560 ohms, and 12 ohms, and unknown resistance. Oh, speaking of unknown resistance, I'm gonna be, hold on, let me get my ohm, not my ohm meter, my multimeter, because I need that for this project. Let me see what's wrong now, because it tells me to open something and it says that there's a warning now. Oh, okay, it's telling me to end my stream. No, never mind. I'm just kidding. Alright, I will be very quick. I think I have my multimeter somewhere right here. Yep, here it is. Oh. Alright. And can't believe some of the necessary things I'm forgetting, such as the multimeter or the electrical tape. Now I do need to know like the bounds at which you guys can see me, because if I put the, for example, the batteries out of it, then there's no point. All right, so right here, okay, I'm gonna actually, you know what I can do instead of having like bounds, I can just raise this up. Oh, okay, that didn't help. That probably made it a little worse, actually. Alright, I'm just not going to touch it, because the thing is made on like a swivel arm, so it swivels and it moves around. Alright, but that's okay. That's alright. Alright, let's, hopefully the batteries are good on this guy. Oh yeah, very good. Alright, I'll put you Oh, I forgot about the microphone. Oh, I should probably move that to, like, closer. There we go. Alright. Now I can move this. There we go. Perfect. Alright. Now you guys will be reading the ohms and voltages and various other things while I'm fixing this guy. And then I'll, be answering your questions. So, okay. Why is one of the legs of the potentiometer just out? If only I had a... Well, I do have a circuit diagram that I can follow, that I probably should follow, because I don't remember what majority of these things are. Well, by R I mean how I built this, because this was this was a project for my class, and it was for a grade, but it wasn't like everyone had to do this. It was a project, basically. It's like, if you want to make it, you can, and go for it. If you don't want to make it, you can do something else. So it's like a choose your own project sort of thing for a grade. And I think I got like a very high grade on this. I wouldn't expect otherwise, because it would, it wouldn't be good if I got like a 30 on this, and my teacher would be like, man, you did so poorly that your project still worked, but you did so poorly that I decided to fail you entirely. You shouldn't even be in this AP class of mine. Whatever. I'm just talking some stuff. All right, there we go. Some of these wires have been in here for a while. Oh, you guys don't even see. Okay, hold on. Let me move my chair then, because it's not centered to my table, so I have to move my. Okay, there we go. So yeah, I've been just picking out components from this circuit board, or from this breadboard. I'm not making a permanent one again. I'm just making a second rendition of this on the same breadboard, which will be fine, because I have all of the components, and even if I don't, I can do stuff that will give me the components to do so. So it's mostly just resistors and capacitors, but there is two specific things that is like very much needed in this project. And this is not like a project where it's like, oh yeah, let's follow this video or this live stream as an example. This is more of like a, okay, if you have the money to do so. Now this does involve money, like everything else, but there are some components, which I will explain later, that cost me, I think, around $12 each, and there was one that was like $7. And the components are very much visible right now, which are these three chips. Now, one of the chips is a AD620AN, which is an operational amplifier, I think, or it's a DAC. It's one of those two. Actually, I can just search it up. I forgot what it's called again. It's a AD. Oh my goodness. 620 AN. Now, just from the basic, it's analog. It's a low power amplifier. Yeah. It's a analog device. Yeah. It's a digital to analog amplifier. So it's a DAC. That's what it is. It's a DAC. And these are not, well, they weren't cheap. I don't know if they are cheap now. $8. No, they're still not, on the cheap side. And then, $8 is the lowest. Then it goes to 10. All right. And then there's these, which are, I think, just bridges or not bridges. They are, what are they called? They're gates. I don't know what. Like I have like it's a like a triangle. Wait, it's like a semicircle, and then with two lines and then an output. So okay, let me just TL084CN. It's a... Oh, it's an input operational amplifier. So yeah, I was correct, but I just messed some things up. This is a DAC with an amplifier in it, and these are operational amplifiers. You do need 2 or 3. I think you need 3, but in each one of these packages there is 2, so you don't really need all 4. But this so this turns the digital signal of your computer, or of the computer, to read the analog signal of your brain. Kind of. It's weird. It's weird. And these amplify the signals in your brain. So it essentially just reads. It doesn't interface, it doesn't do anything, it just reads. But it's called a brain to computer interface because you can read the brain. That's the way you interface it. You just read it. You don't like talk to your brain. It's an EEG. You just read it. Well, I mean, we could do something with this on the outer side. So like once you read it, once there's a threshold of some sort, you can turn on an LED once concentration levels are above a certain voltage. In this case, it would read an aux, like a microphone. Okay, so now that I have that, capacitor fell. Now that I have that and kind of explained that, if questions do arise on these chips, I can once again explain them in a little better detail. But as of right now, we have 3 chips, which are... Oh wait, I didn't read the chip. How much does this chip cost? Oh, these chips are very cheap now. They're 80 cents with $5 delivery. Or on eBay, they are $3.50 free shipping per one. So $7 plus $10, yeah, $18 basically, with like tax and stuff. So for $20, you can build this device that can read a brain, which is quite crazy. So I need my previous Google slides that I made before for this, because I had them open, I have them open. There we go. So we have the 80, 60. Hold on. Should I bring the camera closer? Let me do this. Let me now. Okay. I can only do it if I can like compact everything together. All right. All right. That's good. Let me. All right. That should be good. Once it stops swiveling, we can continue on. So we have the operational amplifier. Then we have the two. No, we have the DAC and then the operational amplifiers. Okay. Oh, okay. So no vibrations, or as little as possible, because if I like shake my hand, the camera moves as well, which is okay. So I think the chat works. I hope so. Let me check it out. Let me see. I think if I send this, I think it just doesn't work. Hold on. Why does it? Oh, alright, there's my multimeter. Okay. So where is it to? Okay. I think... Oh, wait, you know why? Hold on. Let me see. Let me see if this is the case. Because this is the first time of me like implementing chat into a stream. So I'm not the best at this. Okay. Can I do this? Oh, there we go. Alright, cool. So yeah, that worked. I really hope I don't have to like... Okay, it just there's a little bit of delay probably. So, alright, let's continue. So we have this, we have a couple of potentiometers, capacitors, and the basic analog necessities. No transistors, no amplification circuits, just filtering, and digital to analog converter. That's it. Nothing else. Very simple. So now the circuit design. Alright, there we go. So I have a resistor. Okay, actually let me split these up. Like the wires, I'll bring in all of the wires later because that's where it gets confusing. Which I might almost have to do immediately because I already have to plug in like the battery terminal or like the battery connections and everything. But it's just to make it simpler for now. Okay. So I have all of the resistors already well, all of them, majority of them, because the stickers fell on some. Oh, another capacitor fell. The stickers fell on some, so I can't read the values of them. Well, that's why this guy is here. So let me start doing stuff. So this guy is... Oh, I have to get rid of the stickers because the way I did it was by numbers. So it's, I mean, by the colors. So it's green, blue, brown, silver, I think. So let's see, 560 ohms. So time to find 560 ohms. 270, 220, 220, 12, 1 mega ohm, 12. Do I really not have it? Oh, here it is. It was out of frame. Let me bring all of them, because maybe just in case. Okay. So 560 ohms goes from pin 1, which I think looking at it like this, I think that's the... Yeah. So it's from here to here. Right? Oh, okay. Yeah. It's from there to there. But to make it simpler, I'll move this one slot over, because I'm going to have to put a positive onto this side to then bridge it over to the third pin. So just to make it simpler, I'm gonna do that. All right. So then just bridge this and this will not otherwise be occupied. All right. One step done. 2 pins connected. Nice. All right. Now wire. So we can do from positive here, boom, to, well, See, I would just bridge it over to 1. Here, let me move my fingers. I would just bridge it over to 1 and then move it to 3. But I don't have the wires for that because I only accounted for making this semi-permanently. So I'm not going to move wires all around and just do this. Okay. Now, wait. Oh, okay, there we go. So now I have the negative, which I don't have like negative wires specifically. I just have red and orange and green and white and brown. Okay, so I have just a lot of different colors, so I hope I can distinguish between the... Wait, what? Why is it making me... Or why did I make it that way? Okay. I guess... Okay, that's very weird. Alright, hold on. Let me get a wire. A long wire, because I remember... One wire here. Boom. And one wire here. So these will be the power wires. The negative 9 and the positive 9 volts. Now these are very, very necessary, because the entire thing is powered by 2 9-volt batteries. And the reason that is because the DAC that we have here has a limited voltage to... I think I got rid of the... Oh, okay. It has a limited voltage of... Let me get the PDF open. Let me look at the data sheet. It is... Input voltage... plus or minus 15 volts. So theoretically, I could put 15 volts on here and it'll be perfectly fine. But I'm not going to do that. First of all, because I don't feel like it. Second of all, I feel like making this portable, so 2 9-volt batteries will suffice perfectly fine. And also, it'll have a higher gain with higher voltage. But I don't really care about that because I care about the clarity, which in this case will only give me, you know, the boosted 12 volts from like the wall or something. Okay. So pin 1 goes to... Wait, what? Okay. I have such weird wiring diagrams. Okay, yeah, this is 9 volts right here. This is 9 volts. I have to remember that. Where's the ground? Pin 5? So if this is 9 volts, this is ground, so 5. All right. Pin 5. Wait. Yeah, that's pin 5. Okay. Pin 5 is ground. Cool. We have that connected. Okay, pin 6, which is the one to the left of it, in between yellow and white, is moving somewhere. So pin 4, the one all the way on the left, no, the one all the way on the right, is negative 9 volts. Which, how do I have it in here? Oh, it's on a different rail. That is weird. It's on a... Okay. So this is 9 volts. What? I am so confused. Oh my goodness. I made this circuit and I'm still so confused. Okay. So this right here goes to where? I do apologize. I looked over the circuit, but I am still very much confused because it is... Alright, okay, whatever. I'm just gonna follow the wiring diagram that I have and not the circuit of the board, because I made two. I used Tinkercad to wire this all together to display like how you should wire it. But initially I made a circuit board. Like a wiring diagram, basically. So I'll just follow that. I'll just follow what I made in there. Okay. So 1 and 8 connected by a resistor. Pin 7 is connected to 9 volts. Alright. So this is 9 volt. Okay, this positive 9 volts. Boom. Alright. Then I have what? Oh, pin 6. Okay. Let me connect this to pin 6. Wait. Yeah, this is positive. Okay, 5 volts. Wow. All right, hold on. This is so much more confusing than I thought it was going to be. Okay, that is positive 9 volts. Let me change the wire then. Then I have ground on the opposite side right here on... Oh, I'm looking at this so wrong. This is... I do apologize once again. It's been... Okay. This is 9 volts. This is 9 volts. Okay. What I've been trying to do is the ground. 5 is ground. There we go. Alright. Let's not touch that anymore. Pin 6, right here, in the middle of these two, go to some arbitrary thing in the... whatever. This placement right now does not matter. Pin 4 is where we're trying to be, right here. Pin 4 is negative 9 volts. So let's use... Do I have any other contrasting colors? Contrast. Green. Do I have any other colors? No. Okay. I'll use green. So 4. Boom. Is negative 9 volts. So we have negative 9, ground, positive 9. So I have a voltage difference of 18 volts because it's from negative 9 to positive 9, which is negative to positive. Negative 0, positive, and then if it was just 0 and positive 9, it would just be 9 volts. You get it. You get it. You got it. Good job. Alright. That part is done. Okay. Second part. Oh, this is from 6. So from this arbitrary thing, instead of this wire, it should be a resistor. Specifically a 22 kilo ohm. 22 kilo ohm. There we go. Okay. So from 20. Oh, okay. I see. That's what I should have done in the beginning anyway. I'm gonna move this 3 over. I'm gonna move this 3 over. There we go. And then I'm gonna move this guy 2 over. So now I have space, or I have space for 4 things for stuff to happen. The reason I made it so compact is because, well, I just wanted to like jumble everything up so the teacher didn't understand. But he didn't understand anyway. I just showed him the final product and he was like, wow, that's crazy. Alright, this is the other wire. So this is negative. Boom. Wait. Ground. So yeah. Negative 9 volts. I think. Once again, I'm okay. Sure, whatever. So 22 kilo ohms from here to the middle somewhere. Doesn't really matter. Alright. That's the resistor connected. Now we have from the resistor a capacitor and then another resistor. So let me see. Yes, okay. So I was right. So we have a capacitor of 220 nanofarads. Right? Yeah, that's 0.22 microfarads, which is one of these small capacitors right here. And if it was just a zoom, will it not automatically zoom? Please? Oh, you were just there. There we go. 0.22 microfarads. If I were to turn it the proper way. There we go. Alright, cool. So that's in series. And that is in series with the resistor. So we have this. And then we have the resistor. Okay. There we go. Now that's in series. It might not look like it, but it is. And I don't think polarity matters. Oh. Wait a minute. I think everything... Okay. It does. Because I think everything else doesn't have a necessary polarity. So technically this is high frequency, but it doesn't matter. But I still feel like I should. Okay, what is 223K capacitor? I still need to figure out like the coding or the code names. Alright, that is a 0.022, so 22 nanofarads, which is, I think, actually the one we need. So we got lucky there. This guy, 22, no, we need 220 nanofarads. Okay. So where's the 22 come in from? Alright, whatever. Alright, so that might be the issue. Because I have all of the capacitors polarized, and I plugged them in so that it just went one direction. It just went up. It didn't go down. So that might be the issue. Let me go back to the main thing. And then I do have this circuit board. Right here. Now this is a very, very populated circuit board, as you can see. And there are still capacitors on there. Now these capacitors are not the ones that we need. Unless there's like... No, there's not. So I will have to suffice with polarized and one-sided signaling of the brain, which should be fine, because my project, my rules. Alright, let me adjust myself so I can, there we go, so I can sit. Alright, back to business. 220 microfarads. Where is it? Oh, it's already on here. Alright. There's that. Then we have a 10 microfarad capacitor from... Where's 10 microfarads? 0.1 microfarads. 0.022. 1 microfarad. 0.022. 0.022. 10 microfarads. Alright. So here we have a 10 microfarad capacitor which stores, I think, the very, very noisy signal and brings it down to a comparator. I think that's what it's called. And the positive needs to go... Oh, that's weird. Why did I do it that way? Okay. So it pin 3. So this pin right here has to be the negative side. Oh, that's gonna be a... It's gonna be a long stretch. Literally. Boom. Alright, and now, does that capacitor need to be connected with anything else? It does. Okay. Oh, that's not connected still. Okay, it would help if it was connected. Let me... So you should never, like, jam two components into each other on a breadboard. But when it comes to, like, loose fitting components, I mean, go for it. Breadboards are pretty cheap. There's no loss in very, very cheap components. I mean, they also, like, mass produce them by the thousands, not hundreds of thousands, because people want to build stuff like me. Okay, so there we have it. Capacitor, both capacitors are plugged in. Now the way I did it is because the negative is already pointed out, and because all of my capacitors except for one is polarized, I just made it go with the circuit. So the negative of this capacitor goes with it. So it's just single pass through. If this was non-polarized, this would be the filtering capacitor for the AC, like all of the digital noise that it would be hearing, like for all of the frequencies and oscillations. But it doesn't. It just goes one way, and doesn't really do much. So let me do this. Then I need another resistor from this line. So from this line right here to pin 3, or is that pin 2? Can't really tell. Let me see if my schematic is better. Resistor to pin 2. Okay, that's very weird. So a 12 ohm resistor from... Yeah, okay, 12 ohms. I think I saw some... Yep, here it is, 12 ohms. Alright. Oh, and it fell. There it is. Alright. So pin 1. Yeah, pin 2 or 1? Oh, pin 2, because pin 1 is the power for it. Okay, I'm gonna actually go on the outside. I mean, of course I will test the circuit afterwards, even though it did take me a couple of days to build initially. Like, schematics and stuff take time, but I like this stuff. That's why I do it. Okay, 12 ohms goes there. Oh, and to the output as well. And I guess to the output, so it also bridges over to pin 4. I think. That's what it says on the. So from pin 2. To pin 1? Okay. I mean, makes it simpler. Kind of confusing, but okay. Alright, let me do this. I'm trying to find like what are the smallest wires I have to not waste any others. But it doesn't seem like I can scrounge wires. Even though I have like tons somewhere, I don't have tons somewhere here. Worst comes to worst, I just start cutting resistors for the pins, because I don't think there's many pins that I need to use. Okay. Okay, let me do this. What else is there to connect? Then we have a 270 ohm or kilo ohm to ground. Yes, to ground. Okay. And not, let me check back. And not to the negative 5 volts. It is negative 9 volts. It is to ground. Okay, so we have this to where? Or I mean from where? After the 10K? So when it made the connection, so right here. So from here to ground. There we go. All right. And that is ground, by the way. The negative rail is ground, the positive rail is negative 9 volts, and the positive rail on this side is positive 9 volts. Whew, this is gonna confuse me so much. Okay, now we've only used one of the 4, I think. Yeah, we've used one of the 4 on this one because this steps it down the most, so it takes the most amount of power, or like passive power, because it goes from I think the output of these, or this one specifically, is 8 hertz. I think very loosely. I think it's 8 or 10, 8 to 10, something like that. Okay. So we have that done. Now from there, next step, from the 12 ohms that we've plugged in back on itself, we branch out from here as well. So from the 12 volts, 12 ohms. Okay, now to a 220 nanofarad resistor. Okay, hold on. Yep, that's from the same branch. So 220 nanofarads. Zero 0.22. No. 0.22. Okay. Okay. So this one takes the output. Actually, let me move these wires so I can and you guys can also see. So the output from here, okay, there we go, is this positive, negative to positive, okay, so negative then. Okay, the output from here is 30 hertz, I think. So this one is, oh, it's at a bridge, so negative. Oh, this will be fun. Okay. Where is this capacitor? I am utterly confused. Okay. I did forget to plug the... Wait. Yeah, I did forget to plug in the positive and negative 9 volts. So this, where is it? So, okay, yeah. Red and small wire. Green, sure. Positive VCC and ground. Where are they though? That's what I'm trying to find. I don't think it matters. I do not think it matters. Because we have... Wait, where is the other thing connected to? Like, I know it, I seem like very not knowledgeable on what I'm trying to do, but which is fair, which is it's a fair statement, I guess. But it's been a couple of years and I haven't touched this since like 2.5 years. Okay. Why is that? I am not making a circuit board like this ever again. Okay. Alright. Let's continue. So from the 220 nanofarad capacitor, there's a 4-way junction. There is a 4-way junction to a thing. I don't know what that thing is yet, but I think it's the crossover from the low pass to the high pass filter. So it's 22 nanofarad, then another 22 nanofarad. Oh, that is weird. Why couldn't I just get a... What? Why can't I just combine the 22 nanofarad capacitors together? That is super weird. Okay, so 47 kilo ohm resistor from here to ground, which, fair enough. You gotta filter stuff out. Alright, there we go. I have to make sure they don't touch. Alright, there we go. Alright. And then from that resistor you have another 22. Oh, you have another 22. There we go, 0.22. I mean 220 nanofarad capacitor. Okay. So we have positive there, so negative here. Okay. There we go. Another capacitor in. Okay, how do I... Oh, why did I make it like that? That is so weird and like actually dumb. Okay. Then I have another 22 nanofarad capacitor somewhere, which I hope has long-ish legs for it to work. So the positive positive. Okay. Instead of this 22 nanofarad capacitor, yeah, there we go. I will just use this 22 nanofarad capacitor and just bridge it over. Now the reason being is because I am limited on my resources, and if I were to, you know, use them sparingly, then this will work. And if not, I will need to desolder stuff, which right now I don't feel like doing, but it might have to come to that. So let me do this. Let me connect it back with the resistor. Alright, there we go. Cool. A third of the way done. Third of the way there. Alright. Okay. Why did the chat just disappear? I was clicking. Okay, fair enough. Great. Do this. Do this. Okay, let's see if I can still remember how to bring the chat back, because I feel like it would be really funny to. Oh. Okay. I guess we have the chat back, but it's not. Okay. I guess it'll be like that. All right. Okay. It's not exactly how I wanted it. I want it to be like legible, but that's okay. All right. 1/3 of the way done, and then it'll be fine. Yeah, it'll be fine. Okay. Now we have this capacitor. Oh, with the other capacitor, this guy, yeah. Okay. So now we bridge the wait, what is this? Okay, this is that, and that is supposed to go into, oh, okay, so yeah, I take this out. Yep. And then the negative of this guy goes into the positive of this guy, and then the negative here. Okay, there we go. Right? Hope so. Hope I didn't mess that up. Positive, positive, negative, positive. Yeah, I hope so. Actually, I'm gonna move this capacitor. So for more clarity, as you guys know, I'm trying to make this better, but it's already not really working out because you guys can't see what's going on. And the positive, now the funny part about this, the positive of this input goes to the ground, which is weird. So are you using any microcontroller to manage the output of the data? So the great thing about this device, which, the great thing about this device is it takes the input of the brain and it outputs it to any aux cable. So it's just analog output. So any analog device like a Arduino, a Raspberry Pi, any ESP32, any LoRa board, anything that has a digit or an analog input can receive this data. But to manage it, so like a visual demonstration I will use is any recording software. I don't remember what the recording software is called, but it's like a very simple recording software. And I'm afraid if I like minimize my OBS, it'll just ruin everything. So I'm gonna do that later. But right now it's just a recording software. But yeah, you could use any microcontroller to manage this, which I probably will be using in the future because it is fun, and I can like think of a color, or not even that, just very simply, it's concentration first. So here's what it does. I have it in my little notes here. So here's what it does. So stage 1, which is this, or not really stage, but like first step of the system is it takes the input of the 9 volts, the positive 9 volts and the negative 9 volts, and it just amplifies everything. So it takes the very, very weak signals and it amplifies everything. So, and then it converts it. Awesome. Oh, that is true. I could put it to like a web socket, and then just you have a graph of the brain waves, or like the brain signal, and then once it reaches a certain limit, I don't know, something happens on the stream, which is like, oh, the camera flips, or, well, I don't know. I don't know, just something very simple. And then from there, it like shortens it to 60 hertz, which is like the main frequency of like the walls. So it like gets rid of that, you know, because you don't want any noise in the background of 60 hertz, because that's like the most abundant signal, or like 50 or 60 hertz, doesn't really matter. And then I put a high pass filter for the brain, which is, I think, around 7 or 8 hertz for the what's it called, for concentration. So like alpha and beta waves is 7 or 8 hertz, and because this is like a difference of the brain, if I had like a picture, I would definitely like display where I'm trying to like make this happen, but whatever. And then, oh, that's the second stage, or like the second step of the thing. And then it amplifies it again by reducing the data. And then the third step, which we haven't done yet, but I guess I should keep going so I can explain everything while I'm displaying the data. Okay. So now I have this capacitors connected. Oh, I built it weird. So these two capacitors and this jumper wire should be connected on the opposite side for simpler connectivity, contact, I don't know, or connection, I should say. But I didn't. So I guess we'll just wing it. Okay. 47 hertz, or 47 kilo ohms is grounded, okay, and then 220 kilo ohms is, why was that grounded? Oh, that's from the other stage. Okay, my bad. Okay, now I have the other resistor connected to the micro. Oh, it's connected in series. Okay, so where is it? I need 220 kilo ohms. There it is. So it's the output to the input of the negative. So like this. I mean, it doesn't seem right, but that's what it says on my, the output to the second capacitor. Yeah? I mean, is there another capacitor? There's not another capacitor. Okay. So it's capacitor, alright. Then it's, oh, okay, I get it. It's from a different source. Okay. That makes a lot more sense. 22 microfarads. Okay, this is negative. So this has to be negative as well. Alright. There we go. That's negative. And now I put this to the output. This is not great. Good enough. I put the resistor on the output of that. Alright, that should be good. I put the resistor, put the ground. I didn't connect the I didn't connect the power to these two yet because I'm gonna do those last, like absolute last, because I feel like that's gonna overcomplicate things right now. So we're almost there. Yes, we're almost there. Okay. So now we have the other two stages. You should have that yellow jumper connected to the other side. This yellow jumper? there's two yellow jumpers. I'm guessing this yellow jumper. So okay. This yellow jumper positive is negative 9 volts. And this goes to the negative of the operational amplifier. The green, this green right here, is the ground for everything, so 0. And this red, this positive, is positive 9 volts. So we have two 9-volt batteries connected in series with the net voltage being 18, but we're taking the, hold on, how do I orient it? Oh, by taking the middle, which is going to be ground, we have a positive and a negative difference in voltage, or a charge potential. That's what it's called. So that's the reason this yellow jumper is on the other side, not on this red, but on this red. Hopefully that makes sense. If not, I will explain in further detail. So now we have, wait, where is this from? Oh, we have the output. Oh, this is not going to be fun. So we have the output of this leading to a 180 ohm or 180 kilo ohm resistor. So where is it? 180 kilo ohms to another pass somewhere. If only I could see. Okay, there we go. That to that. Alright, there we go. This is like an arbitrary place right now. We can bring that down so you guys can see as well. And then we have 180 kilo ohms connected. Oh, that's just the center. Okay. So then we have a capacitor of 100 nanofarads, which is 0.0 or 0.1 microfarads, which is this guy, and we connect them to ground, which I can just make ground here. Okay, should be good. Oh yeah. That's all right. Yeah, it's very complicated because I have a lot more. Here, let me bring in all of the. Yeah, I have a lot more jumper cables, so it's going to be very confusing very quick. That's why I keep them out of the frame, and I try to make it as simple as possible. Okay. Now this is not like easy stuff. Like to put it on a breadboard, sure, but to explain and like understand it, it's not like very simple. I'm not saying this so like deter you guys from doing this project, but you can take it as like an educational experiment. You guys can like, you know, say, look at this. This can read my brain, and I can show it to you once I'm done. That how this works and how you can make this work too. Thank you. I'm trying to make this entertaining as well. So, all right, 100 kilo ohms to another side. So from this to this. Oh, the negative. See, bad labeling doesn't help. When you label bad once, that can mess you up for many hours. That's why I don't make my own PCBs, because I tried doing it a couple of times and it didn't work out so well. Oh, also this positive gets shorted to ground, so that's very simple. And while I'm here, I might as well take another negative wire and put that to ground. See this guy? Yeah. There we go. Alright. So now that's ground to ground, right? Yeah, that should be ground. Alright. Now let's keep going. So the positive is grounded, the negative is connected from one resistor to another resistor, then from the initial resistor there's another 180 kilo ohm resistor, which 12 ohms, 220, 1 mega ohm, 100 kilo ohms. Oh, there's another capacitor. Oh, you know what? So instead of this yellow jumper, I actually have a very, very small jumper pin. That's probably why I made it. And it's a lot simpler than having very bright yellow. This is why I try to do stuff right the first time, so it doesn't fail. Yeah, I need like pliers or something. This is gonna be... Yeah, this is very, very, very small. Like extremely small. Oh, it's jumpy too. Okay. Let's try a diagonal. Oh, that worked. Alright, cool. We saved the jumper. Let's go, we saved it. Alright. 100, what did I say? 180 kilo ohms again? Okay. That should be fine. Now to use the multimeter, because I've lost all of my other. So is this 20 ohms? Okay. I'm guessing this is also 20 ohms because it's yep. Okay. So drop that there. All right. Let's check this one. One of these should be 180 kilo ohms, and I hope it is. 10. Okay. There is 220 or 270 kilo ohms. Why? There's no way I lost parts, or I lost what? Okay. From that same 180 kilo ohms. Okay, I'm a little bit confused now, because I think I measured. Okay, this is the... Oh, I didn't measure this one yet. And I did use it because it's bent up. So I really hope I don't have to start cutting resistors. Oh, 130? 120. Okay, why is it dropping? Okay, hold on. Get the negative, have a good contact. Let's get the positive to have a good contact. It's 130 kiloohms. Alright, you know what? We'll just use that. That'll suffice, because it's not really that detrimental past the first filtering stage. This is just like minute differences in frequencies. So it's like instead of 7 hertz, it'll be like 6.6. Something like that. It's just like something like that. So okay. So we need this. Okay. I'm gonna rearrange these. Yeah, I'm gonna rearrange these resistors because first of all, I don't understand where these are supposed to go, and second of all, they're like in my way of everything, so I'm gonna, there we go, put these in here, change the position of the capacitor in here. There we go. Much simpler. Much simpler for me. Alright. Where did the resistor go? Is it this one or this one? Oh, you guys can't see. Oh, dang. Alright, let me move this here. Let me move all of the components back, because I guess I got lost in the chaos. $140. Alright. Oh yeah, because it changes with temperature. So from the center point, yep, to a random location. Okay. All right. And then from there, the 180 kiloohm goes to the output of its, wait, why don't I just, oh, that's so much worse. I don't know why I did that. Okay, hold on. Let me take the output. Output is this. Okay. There we go. And then let me put it here, which here you guys can't see, so just believe me that the output is there. Then I have a 100 nanofarad capacitor, which I think is this guy, and if not, let me just look just in case. 0.01. I think that's 10. I don't remember. I don't remember what the 223K capacitor is, so I'm gonna look back. It's 0.022 microfarads or 22 nanofarads. Okay, so oh, that 22 is actually going to be useful in like a step. So 100 nanofarads is, I guess, 0.01. All right, very simple. Wait, that's already grounded. Oh, so I guess we're on that step. Okay, so we take this capacitor and we short it, or we don't short it, but we take it from the resistor we just put on the output to the resistor we just put on the input. So it's a smoothing capacitor for the input and output side of the system. There we go. Okay, that is like very, very wacky soldering or wacky placement. I don't know why I'm moving it. There we go. So very wacky placement because I just have to trust my intuition that I made this right. Because I have zero clue. I can't see much. So I'm just going to trust that I made this right. And if I didn't, I guess we'll see in the results. Alright. And then... Alright. So I found the 1 microfarad capacitor. Now, this is probably one of the shortest, if not the shortest, capacitor legs. Why is it not focusing properly? Like, it's weird because it's not... Okay, whatever. So, let me go back to the... Okay. So this is polarized once again. So the output of this... Okay, let me do another pin. Or let me do another thing. So it goes from the output... There we go. So this is the output of the last filtering stage. And then we go into the high gain filter. So this is the output of the last filtering stage. So then we go to a 1 microfarad capacitor, which takes the positive from this side. So it's reverse polarity to the negative of this side. Okay, there we go. So we have the capacitor right here. That's the 1 microfarad one. And then we have a 1 mega ohm resistor bridging it to ground, which is the only 1 mega ohm resistor we need to use. So I guess that's good. And I'll make it simpler for myself just to put it on the edges of the two sides. All right. Then from that ground, we make a bridge from the connection point of the resistor and capacitor over to the positive input of another operational amplifier, which I hope my intuition is right. Positive is the furthest one. Hope so. I guess we'll see. Positive is done. Now the negative side is going to be very interesting, because here comes in a potentiometer. Now I already bent one of the pins because we don't need one of the legs of the potentiometer. We just need one. So I guess I'll put it down already just because we need it to work. Okay. Alright, there we go. Alright. That should be fine. No, that's not fine. Okay. I can already see that it was like bent out of its thing. So let me... This is like... This is like one of the worst components to put onto a breadboard. Like a normal potentiometer, sure, that's perfectly fine. But a small scale potentiometer is not fun. For me specifically, but I mean, could be fun for others. I'm not judging. Alright, there we go. Alright, that's in. So now we're very close to this stage right now. Actually, we're like basically there. So then we have the negative side. Wait. Oh yeah, we have the negative side connected to a bridge. And okay, we're running out of space already. I'm like baffled how I built this the first time. All right. I mean, on how I built this the first time. Okay, so 220 kiloohms. All right, it doesn't matter. I'm just gonna use 270 because I think I use a 270 on this. All right, and then the negative bridges to a point, and then from that point it bridges to the sweep of the potentiometer, which this is okay. This is going to be the point that it bridges to, and then the point on the potentiometer is going to be here. Okay, and then to that arbitrary point once again. All right, here we are. Here we have it. We're like, I think this is the last actual thing. Kind of. Yeah. This is the filtering circuit. Then we have the output and we're done. Actually, it's going to be weird because I have to use this, which I'm going to have to jump from here to here. I hope won't cause an issue, but I guess we'll see later on. Alright, so we have this resistor connecting to the potentiometer, and one of the pins, the ground pin, can actually be... Actually, wait. Let me take this resistor off. I'm going to go back a step. I'm going to take this potentiometer off too. And then just bend this. Bend this so I can put this into the ground. Okay. Press down. No. Alright. I'm going to use the other leg. It doesn't matter which leg you use for the potentiometer, as long as it just fits into the circuit. Oh, I broke the potentiometer. Okay, do I have another one? I can quickly get another one because I have cutters, but I broke a potentiometer. It's not like that detrimental. It's just it's just like a pain to find and get one, or I guess find and get another one. But I have the board. I have the board of stuff. So hopefully the oh, you know what? Oh no, that's wait a minute. I think I just have a potentiometer somewhere. I remember. This project has gone from a 20-minute, actually not even a 20-minute, but like a long ordeal to an even longer ordeal because the potentiometer broke. We could skip the potentiometer step for now, and I feel like that's going to be better, but I can't adjust anything for the high frequency cutoff. So I'm gonna leave it as that right now. All right. So we have the resistor, a 270. Output going to an arbitrary point. All right, there we go. All right. And then going from there, wait, oh, wait, where's the negative? Oh, that was from the negative. Okay. Yeah. I was just confused on what step we were. What step we were on. Okay. So now from the negative side, we bridge over to the resistor. And then we make another T junction, kind of, to just a 100 kilo ohm resistor. So we branch this resistor from here to here. Actually, I'll make the arbitrary point way easier, because I need to connect a 10 nanofarad capacitor, which, from what I remember, oh yeah, actually, I don't need to make it like that, because, once again, non-polarized, but I know that negative, positive to negative. Okay, so positive here, negative here. Okay. And the resistor in parallel, which is this. Okay. And the reason you would do that is just to filter all the rest of the the things, just to get the specific frequency that you want. I was gonna say 8 hertz, but it's a very it can be any frequency you really want it to be. You just need the right resistor, capacitors, and with enough filtering, you can really get to like sub frequencies if you really want to, but it's like a little too much work for me, so I just prefer to use for the brain, because brain is a very simple 7.3 something hertz. Okay, and then from this point you go to the output. So the output is this. Oh, you know what I can do? Instead of that, I'll probably do that, yeah. So I have this Frankenstein's monster pin selection here. So I'll do that, and then green to the output 2, and then the green to the resistor capacitor parallel circuit. So now we have this as the output, and then, alright, last step, the filtering. 22 kilo ohms. Let's see if we can, I don't remember if these are 22 kilo ohms, but I guess let's see. . Okay, hold on. They are 22 kilo ohms. They are actually exactly what we need. A very long string of resistors with very cold welds on it, but I couldn't really solder 2 years ago, but now I can better. I definitely can better. All right, where is this? Okay, there it is. Wow. Okay, this is gonna be fun. Because there are so many like bare metal points where you just do not want to touch with the other point. All right, 22 goes to output. Oh, okay, I need like another arbitrary point. See, I have this entire mess right here, or this entire free space right here, even though I could have just brought this over here and used a single chip. I didn't realize that, or I guess I realized it too late. What I can do, what I probably should do, is because this is one of the pins that goes to the output, to like the aux cord. This is already one of the pins to the aux cord. Then we have the ground as the other pin to the aux cord, and then we have, and then we're done, right? Because we have the looping back. Yeah, we're done. So this is the last stage. We have 12 ohm resistor, 220 ohm resistor, two capacitors left, and yeah, we don't need this guy right here, unless it's a different resistance than we do, but I don't know if it is. $560 ohms? No, nothing like that. But yeah, this is all we need left. These very few resistors and capacitors. Oh, and the potentiometer. Okay. Let me see what kind of space I can scrounge up, because I might just bridge over to other pins, and I do see one already. In the midst of all the chaos in the beginning, I can bridge over to the single point right here, connect the capacitor to another one very close by. Actually, I could move this over and move, hold on, and move this over. Okay, I think that should be enough space. It's a 3x5 right here, 3x5 grid. So if I can just about reach this resistor line. Oh, see, I can, but now the issue is I'm touching the other resistor. Here's what I'll do. Because I'll finally use the electrical tape. Alright. And now, it's well insulated against 9 volts. That's all I needed to do. Okay. Now I can loop it around anywhere. Without a care in the world. Alright, there we go. Cool. Capacitors. Oh, resistor is there. This is one of the. Oh yeah, let me get one of the outputs. So this is. Oh, that's what I did. Okay, let me get rid of this. I guess no. I guess I should. I guess I should do this first. Do this. See if this gets plugged in. Oh. Okay. I'll plug this loose wire so the positive stays in. Okay. Then I have the ground, which I will just plug into a random point with another wire in place. I mean another pin in place. Okay, hold on. Okay, there we go. That shouldn't move anywhere. And then we have the, what is this? This is positive 9, ground, negative 9. Yeah. Okay. Wait. No. It's opposite. Even I said so. Yeah, negative 9, ground, positive 9. Okay. It's a good thing I caught that, because it would have blown up all of my chips. Alright. Let's do this. Bring this down. Pin this in. Okay. Yep. And then we have the positive. Imagine after all of that, it just blew up. Positive can be alright. That should be good. And if it's not, I'll just push it down. Actually, I'll just push it down now. Alright, there we go. Okay, now I have these two alligator clips. Where's the other one? Oh, there it is. Now I have these two alligator clips, and one of these can now go on the output. Now this goes into any aux cord. Boom. Then we have another one to the ground. Boom. There we go. Look at that. We can now plug it into aux. But we're not done yet. We still have like a couple more. We have 4 more components to put on. Oh wait, no. We have 4 plus. We have 8 more components to put on because we still have to provide power to these chips. So, forgot about that. Okay. Let's do this. We are there. We need the capacitor. 220 nanofarad, 0.22. There it is, 0.22. Now this is from going to a polarized capacitor of positive, so okay, positive to resistor. Boom. There we go. Alright. And then we have the polarized capacitor leading to the positive of the gate, which is a 10 microfarad capacitor. So this one. Positive of the gate. Oh. Okay, I'm gonna have to move this one pin over, and hopefully this resistor reaches, because now I can do it. There we go. It's a lot of trial and error, just like coding, but unlike coding, I don't like it. Or I mean, unlike coding, I like this. Alright. Now after this, so on the same pin as that, I have to bridge it to ground. Okay. With a 270 kilo ohm resistor. 270. Was this 270? No, this was like 500 something ohm. Let me see. This to this. Yeah, 560 ohms. Okay, any of these 270. Okay, we need 12, so oh, we have 12. Okay, we don't need this then. We don't need this then. Okay. A 10 kilo ohms. Nope, we're not gonna need that. We have 2 more resistors to see. 10 ohms or 11 ohms. Okay. Now we have this one. This is probably like in the mega ohms region. 54 kilo ohms. 54 kilo. I mean, okay. I do have a couple of resistors, because this one is actually like needed to be almost precise. So let me read some of these resistor values and see if they oh, my water bottle fell. Okay. Some of these resistor values. $54 kilo ohm. This is the closest one we need so far. If there's any of them that are like 200, it's an immediate take. Oh, this one's in like the mega ohms. Yeah, no thank you. I will not be dealing with that right now. This is 18 kilo ohms, maybe. $19 ohms, no thank you. This is like very low. This one will be very low. 1 kilo ohm. $3 kilo ohms. Okay, so even putting it in series will result in like 60 kilo ohms, which I cannot do. So I'm gonna look at my board and see if it has any resistors that will work for our case. So what is a... Oh, what is a 270? Okay, hold on. Let me see. I guess I need to know, like, the stripes then, because... I mean, I could definitely just guess, but... What's the fun in that? I mean, what's the fun in knowing the stripes? One kilo ohm. Alright. Seeing a lot of... What is this one? Okay. Found another resistor. Oh, 208 kilo ohms. Whatever. It's made by heat. That's like almost 80. It's like 200, you know, I mean 270. I could put in series the other resistor, which I probably should, which will probably be very, very easy to do. Is it this one? Or is it the long one? Because if it is, then I might just put in my soldering iron. Yeah, 260 kilo ohms then. I mean, it's not gonna be fun to solder very thin, very small points, but I might have to. No one really likes to see me solder, but you know what? Whatever. I'll do it anyway. I will do it anyway. Where's my soldering iron? I put it away for this video because I didn't think I would need it, but now I'm looking around and I cannot find... Oh, there it is. Okay. Very, very easy. Very simple soldering iron, too. It's, here it is. It weighs just about the size of 3 iPads. Okay. There we go. Now, it will not be a good soldering job because I don't think I can make it a good soldering job with how poor this can turn out. And I also don't have my my soldering tools with me, so I guess I'll just have to see. And it doesn't matter if the weld is cold as long as, you know, it's welded on. So I guess let me move it closer to like the middle of the screen so you guys can actually, you know, see it. Alright. Should be hot enough. You know, if I put in some... Oh yeah. Oh yeah, that is definitely hot enough. Look at that. Oh, that's going straight into the camera. That's nice. Don't breathe that in. That actually might be soldered already. Nope. I blew on it too hard. Alright. Left a char mark on my desk. And it's like very much cold welded. Is that like... Yep, that's like on there. Okay. I'll just cover it up with like a mat or something. Alright. The things that I do for you guys. No, I'm just kidding. But yeah. Let's get some electrical tape. then cover this up. If you just spin it around, it's gonna create a lot of, you know, force that it can hold on its own. It's not gonna like pry out. And we take another piece of electrical tape. And just hide that. Cool. All right. Now we have our makeshift resistor. Well, by makeshift I mean it's just 2 resistors in series for 270 kilo ohms and 2 ground from the positive. Okay. So ground and then positive. Just like that. Very simple. Look at that. Very simple. And 12 ohms to the output. Where's the negative? Oh. 12 ohms. Okay, 12 ohms to the negative and the output. Okay. Okay. We also don't need this resistor. Okay. This is gonna be this will be fun. Okay, that's 12 ohms to the negative and output. Oh, but it's not from the center. So it needs to be 12 ohms from the center, negative and output. So I guess I have to connect the shortest connection I have from the negative to the connection after the capacitor. So after this capacitor has been plugged in, so from here, I guess so. But before the electrolytic, yeah, okay, cool. Alright, that should be good. Now we just connect all of these to its respective positive and negative, like negative 9 volts and positive 9 volts. So, should be easy if I have enough. So this is 1, that is 2, that is 3, and that is 4. Cool. Actually, I can make it a lot simpler. Because this is what? 1, 2, 3, 4, 5, 6, 7? Wait, what? What's the wiring diagram of this? Because I don't really know what it's called. I already forgot. Oh, I can't. If only I could see and hear. L084, and I think it should be saved. It's not. Okay. Let's just go back into it. L084 CN, and that's it. TL? Wait. I guess it is TL, yeah. TL084. CN. Okay, and now the data sheet for that is what? Ah, there we go. I just need to know where is output, where is input. Okay, C. Oh, that's weird. Alright, I was about to plug it in wrong, or incorrect. So the middle, so this top, oh wait, I'm looking at it backwards. I was building it, and at some point I just reversed it, so it's like this. Yeah, okay. But yeah, I was right. So positive is inside, and then negative, and then output. Okay, cool. So it's centered down. So this center is VCC plus. So that is positive 9 volts. Cool. Then I have another one. VCC plus, boom, and positive 9 volts. Cool. Then I have another one. VCC minus, boom, and then negative 9 volts. Yeah, negative 9 volts. Okay. And then there's one. Oh wait. VCC minus. Now if this is plus, that is ground. That means that is minus. Okay. Yes, and then I can take this directly from the battery. Cut this off, and then cut off the other one. Nope. Alright. Now we just make these two good. Pair these two together. Now I'm not going to solder anymore because I don't feel like it. But soldering iron is on. Or not exactly on, but it's like it can be. Okay, that is such a small pin, or such a small place that I can place my pin. Hopefully it sticks. Hopefully it didn't break. Alright. And now, I guess moment of truth. Oh, wait. I forgot. Okay, we don't need that anymore. I forgot about one thing. The potentiometer. We do need that. I'll leave this here for now, and I will see what I have, because I do remember I have potentiometers. I just need to know whether they are the same like size. I need 1K or 1 kilo ohm potentiometers. I will be right back. You guys can look at this battery right here. No one knows, and I just didn't catch that on camera. Okay, that's switches, coils, more switches, more coils. That's connected to ground. Okay. I could just do a very big inductor. That could also work. Now I need it to be large enough that like all of my potentiometers go? I had. Okay. That's just silly. This is just silly. This is just very, very silly. I had like copious amounts of potentiometers and they all just disappeared once I need them. Okay, you know what? I have a plan. I have a solution to my issue. Big inductor. Oh. Big inductor. So, let me tell you something. Inductors are not the best when it comes to filtering out resistors. Or not okay. Let me rephrase that because that didn't make a single lick of sense. When it comes to voltages and stepping down through one pole, transformers or inductors are not good at that. They're good at retaining their voltage once it's charged up, because inductors charge them up in terms of electric fields. So, let's measure the resistance of this inductor and then see how we go on from here. Because this inductor could mess everything up, or it could be perfectly fine. And it's 2 ohms. Okay, that is not good at all. But that's the output, so hopefully the input is a little better. Uh, 93 ohms, which is still actually terrible. So 93 ohms is not good because we need 1,000. 93? Wait a minute. 93. I think I can just manage to put it on a resistor. Hold on. I can just put it on a resistor. Yeah, it doesn't really need to be trimmed in terms of, well, it kind of does. It kind of actually does. $10K. Oh, 500. Okay, yeah. I can put this in, because this is 550 something, or like 560 something ohms. So yeah, this will be the last straw in the haystack with the needle in there. To ground. I don't remember if the potentiometer was to ground. Hold on, let me check back, because we are essentially done. Apart from it not being an actual potentiometer, we are done. Let me see. So potentiometer goes to ground, so the center point. All right, and the center point is not there. Okay, so let me change this. Move it here. All right, now the moment of truth. Let me actually put some electrical tape on that, because I don't feel like burning some chips today. Boom. All right, and now the moment of truth. Powering up, or powering it up. All right. Nothing is burning so far. Oh, speaking of burning, I'll be right back. I plugged in one. I have a thermometer. We can see if anything heats up while we use it. This is like, this creates noise every single time I use it though, so it's 75 ambient, and then the other chip 75. Okay. And now we plug in the other one, the one that will power everything else. So let me move everything out from view So nothing is like too complicated, because you never know. You might get distracted by a battery. But these two are needed for the input, or no, the output. Right here. All right. And then boom. All right. Now this is just working with creating just random noise that it picks up. So it's not doing anything. It just is working. Now, this is not, it shouldn't be creating any weird temperatures. Yeah, because we're not really using or working it. Unless this one is, no, this one is the same temperature. All right. So, oh, let me move it to Celsius, because I feel like more people are going to understand that. Okay. And just for body heat, 91 or 33C. So as a baseline, I guess. If we get to 33C, then it's not going to be so good. All right, let me see where I put in the pins, because I did forget. So you have, where did you put, or where did you put the pins? You put the pins. Hold on, I'm a little confused because I don't remember where you. Where? Hold on. I have a different. So white input, and then this is ground. Okay. Oh, I get it. All right. So yeah, these. All right. How am I going to do this? All right. I have this right here. This is one of my inputs. And then I need another wire. Oh. I have another wire. Now, polarity does not matter. I'm just cutting a random wire. All right. One more. And boom. All right. So now I have two wires that are inputs. All right, cool. So now I just need to do two things. I need to download a program. Now I hope I have this program, but if not, I do not. Okay. I need to download a program first, and second, I need to find an aux cord. So let me first download a program, and then I really hope it's not going to be like a random. Okay, hopefully my stream doesn't go down. That would be that would be tragic. All right, now to find an aux cord, which shouldn't be difficult because I have one like just lying around somewhere. I mean, I said it shouldn't be difficult, but that doesn't mean it isn't, I guess. Because I think just... Okay, hold on. let me get back to the program. No. What? No, just download the... Okay. Yeah, just download it. Alright, there we go. Where is it? There it is, there it is. I found the aux cord. I found the aux cord. I found it. It's right here. You guys don't believe me. If you guys don't believe me, it's right here. Look at that. Real, authentic aux cord. Alright. Okay. Alright. Let's see if I can manage to do this at the same time. So, this will be very, very weird to do, because I'll have two things or three things open at the same time. Alright, I have... Oh, hold on. Should probably do studio mode, because I don't want you guys to see stuff. Window capture? I don't know. Oh, there we go. Right away. Cool. So now I have Audacity open. There we go. Alright. Now Audacity is cool, because you just can do whatever you want to do. And I think I can select... Oh, wait a minute. What microphone is it? Recording device. USB. Oh. Hold on. I have to plug in the aux cord first. Alright, that makes sense. Oh, let me do this. Alright. I have to untangle it. Should be pretty simple. Alright. Untangled. And now, moment of truth. If I get a notification saying aux cord is connected, or aux, whatever, input is... Okay, whatever. Microphone input. Cool. Okay, I don't know why my camera is so shaky, but that's okay. Alright. Boom. And boom. It's just one channel, because as I said before, if I were to make it more complex, it would not be fun. Well, not really. I just don't really care to do so. Alright, hold on. Okay, let me route this around my microphone. Oh, not like that. Okay, hold on. Through my microphone. And then over on the right side for you guys. Boom. Boom. Alright. Now I have that. Let's see if it's warmed up. A little bit, kind of. Oh, one of them is. One of them is a little warm, one of them is a little cold. Yeah, that one is warming up. Alright. Okay, let's see. So now I have a microphone, audio setup, recording device. I don't get it. Sound? Maybe? We don't need output level at all, because it's we're not going to be listening to my brain. So these are going to be the electrodes that, you know, go on my brain. And just for like... Actually, I want to see whether it does record or not, because... 0, 0... Wait. This is just a microphone. Oh, wait. Man. Get rid of it. Okay. recording. Okay, I have zero clue whether this is from my webcam, my microphone, or this. So I guess let's try it again. Alright, it's the same exact thing. Let me see. Alright, let me re-plug in to a different port. Okay. And then I have... Where do I have another mic input port on my computer? Maybe I have it in the back somewhere. Oh, now I have to like go down under the table and look. Okay. Ow. What? How did my mouse get underneath? Okay. There we go. Recording. Oh, I should do this too. Recording device. Oh, you guys don't see the screens. Okay. That is so weird. That is very weird. Okay. Why is the device... Okay, I'm like confused. Alright, hold on. Let me see if... Alright, round 2. Okay, yeah, this is still the microphone. Select, edit. I'm not like good with Audacity, so I can't really import. I can import audio, but that's... No, that's separate. That's different. Mix. No, we're not gonna do that yet. Okay, hold on. It's from here, but I don't get it. Why? Okay, recording device. Okay, it's still not showing up. So here's what I'm gonna do. Back to business. Let's see if I have any other ports. Let's see if I have any. Okay, I have that one. Did that do anything? Let's see. Alright. Recording device. And it's my microphone. Okay. Very odd. Very odd. Hold on. Let me see if... What's it called? Audio... No. Device Manager, I think it's what it's called. Let me see if it shows up on Device Manager. Because I think it would. I think it would just show up. Hold on. Again, my microphone is like taking my stuff. Alright. Yeah, Device Manager. Okay. So we have audio, sound, video, and yeah. Okay. USB audio device. Alright, so that's what I have right now as my aux. Because I have like separate things that can plug into its own thing. can't believe out of all of the issues, this is like one of them. No, there's no way. Mic or aux? Okay, yeah, I'm using my microphone right now. So I don't... Oh, I might have to turn off my microphone for my tests. Because it's going to be conflicting with the other software. That could be the case. Could be. I don't know, but it could be. Alright, let me plug it back into... Alright, let me plug it back into its microphone jack. Okay. Just in case I have to check it once, or I mean check it twice. Alright. So now I open up Device Manager again, just in case. And then sound. Okay, it's the same thing, so nothing really changed, but I might have to see if audio input. Okay, that's weird. That is all right. All right, I'm gonna mute just in case if it, you know, if it has to do something with this. So let me do that again. Yep. All right. And let's see if that's the case. All right. Wait, how do I do it again? Oh, properties. Wait, what? I forgot how to I forgot how to mute. It's not that. It's not that. I can just remove it. Hopefully it's not going to cause any issues later on. Alright, I'm going to remove my audio input capture device. Alright. See you. No, I'm just kidding. Alright. Wait, what? How does it still pick me up? Oh, because the microphone... Wait. Properties. Oh, okay. Wait, can this still hear me? It can. How? How does... Okay. Oh, this is from... No. Default? No. This? No. No. What? Okay. I think my audio input capture is back, and if so, I think it's back. All right. Hello. So I just finished building the EEG and plugged it in. Now I have one issue. I have zero clue whether it works because I have three separate input capture devices. So here's what I might do. I might just set it to my laptop because I feel like that would be easier than trying to configure everything with all of various things. But I don't know. If you guys would say it's cheating, then I'll keep trying. But if not, it's going to be a couple of minute ordeal, and then I could get it running very easily. And I can display it easier because all I have to do is just literally move a couple of things like so, and I'm done. So maybe I'll do a dedicated video on this just for the does this go into your skull? No, it does not. It reads your brain without interfering with anything else. So it goes from a DAC, which is a digital to analog converter, which takes the input of the, it's like a microphone, takes the microphone input, the aux, or no, that output, takes the input of your brain, the analog input, and then it amplifies it, it filters, so it removes all of the 60 hertz stuff, it removes all of the other frequencies that would be relevant to, like fan noise, like not really fan noise, but like high frequency stuff. We just need a certain frequency for the alpha and beta waves. Or delta? Wait, I forgot. I had it in my notes. This was from 2.5 years ago. This was a project I'm redoing from 2.5 years ago. So let me see again. What am I trying to go based? Alpha and beta. So yeah, we're trying to read the alpha and beta waves based on concentration and focus, I think is what it is. So I'm just for simplicity's sake today, I'm gonna run this on my laptop, or not run it, but take the input capture. That's it. Just take the audio capture and run it on my laptop, and you guys will see the screen as well from my camera. So it'll be less visible, but it still will be visible. So whatever, it's okay. And if you guys say it's cheating, well, well then I guess it is. All right. Let me power it up, put in my password and stuff, and then we can have a fun time. All right. Let's see if I already have the program downloaded. I probably do. I do. All right. Now, okay, skip the update, whatever, bring this here. Alright, the average thickness of a human brain is around 6.5 millimeters for men. That's cool. It's cool to know. Alright, let me remove this. Alright. Well, not really. The brain isn't really, the skull isn't really a very tough thing. This tripod is tougher. Okay, let me do this. Oh my goodness. This is this is like, all right, that should be fine. Let me, oh, okay, move the camera itself, not the tripod. Let me do this, that, okay, good enough. Let me, can't believe this is how we're doing this. Alright. Now, because I don't have an audio capture on my laptop, I can just plug this in to the aux cord or aux port on the input, and you get to the juicy part. Exactly. Alright, let's see. Can this recording device should just work. Alright. Oh, it's recording. Okay. Hold on. It's recording from the audio of the thing. File. Input. Hold on. Recording device. This guy. And from here. How is it? Okay. Hold on. I'm still so confused. Because here's the thing. When you select the recording device, audio settings maybe? No, it's... No. What else did I do? What other program? I could just do recorder. Do I have that? Hold on. Let me see if I have that. Ugh. I have a lot of stuff. Alright. I do. Now, which audio... Change microphone. Okay, I can change the microphone. But then... But then why does it not want to change it for Audacity? Speech. Microphone. Okay, I am actually confused. Because here's the thing. I want to change the microphone. But it doesn't let me change it for the microphone. And I did this last time, and it worked perfectly fine. Let me see. Because last time I did this, it did not pick up a microphone. It just worked. I haven't... Hold on. Do I have an aux... Like a microphone? Like an aux microphone? Because that could... solve some things. I did have an aux microphone. I remember that. I did have one somewhere here. Now where? I have zero clue. But I did have it. It doesn't really help, but oh. Well, I'm not drilling into my brain, but alright, thank you. Alright. Let's see. Any microphone components in here? No. Let me see. How does... I'm actually confused. Like this. Alright. Let's rescan audio devices. Okay. Is this... That is in. That is in. That is in. That's in. That should be working. That's in. Alright. Rescan audio devices. Maybe now it shows up. Nope. Okay. Yep. Alright. Weird. Very, very weird. Enable silent monitoring. Gradient, decibel, refresh rate. Okay, not at all what I'm trying to do. Out of all of the things, this is what I'm having issues with. Wait a minute. What if I just... Hold on. I'm just going to look up the solution. I can't believe I haven't thought of that. Alright. I'm going to look down. Oh, I forgot I changed the position of my camera. Oh. Okay, well, it's not that low. Oh. Okay, good enough. You guys can look at the circuit. How to change audio device. That's what I need to do. At least I hope so. Oh, wait, what? That's weird. Edit? And then what? Doesn't really say. Hold on. Preferences and devices? Okay. Oh, it doesn't have preferences. Okay. Let's see. Oh, preferences. Okay. And then devices. Oh. Fair enough. I guess it does. Recording. Okay. Interface. What? I could just, hold on, I could just do this on my computer now. Because at least now I know approximately what to do. So let me go back. Let me do this. Yep, now you guys can see that. Now I can do edit. Oh wait, let me plug in the aux cord first. Alright, that's it. Cool. Now I can do input, wait, oh yeah, this, rescan audio, edit, preferences, and then playback, nope, recording, quality, interface, tracks. Do I not have the ability to change my recording? I don't think I do. Because once it's on, okay, that is device recording, yeah. Okay, I think that changed it. Did it? No. Well, kind of. It's a different audio output or input. So now hopefully, nope. All right. Once again, edit preferences. Oh, maybe this. Oh, that's playback. Okay. Okay, maybe now that changed. Hopefully. Oh. Why did it freeze? Why did it just freeze? Oh, maybe because I have it wrong. Oh, loop back. Wait, now it's on the digital audio high definition device. Okay, now it's on the, okay, I got it. Oh, I moved the stream. There we go. So now I can rearrange the wires, and then I can see whether that did anything. Nope. Remove this. Try it again. Nope. Alright. Now, okay. Put this in the back. Okay. And now I can continue, so this records. I don't know whether it's going to record even when it's looping, because I need to, okay, whatever, I'm just going to explain this once. Alright. I think, I don't know. Why is it looping? Because I'm gonna guess it's still looping. Rescan. Why is it loop back? Hold on. Oof. Why is it loop back? Oh, because it's playback. I think. Okay, and now I can edit this again. Preferences. Alright. Then I can do... Oh, that is weird. Why is it... Why does it not want... Oh, line in! Line in! Alright, hold on. Recording device line in. Okay, hold on. This is crazy. This is... We're getting somewhere. Alright. Oh. Cool. Okay. It's not doing anything. Now if I connect this and this... Alright, hold on. If I connect them together in short pull... Oh, wait. Okay. They're both in. They're both in. Now let me do this. Let me stop the recording. Do this. Do this. Okay, hold on. Let me pitch and speed. Nope. Spectrogram. No. Multi-view. No. I rate. No. Okay. I guess we just have to amplify it now. Because it's going to be like very, very small. So let me try to amplify it. Okay, I think 33 is enough. Alright, I don't need this. Okay? Now, I don't know, I can't see the screen. Hold on. I cannot see the screen. So let me restart. Do this. And then, oh, you know what it could be? Hold on. Don't. Okay. I think I needed to restart it. Hold on. There's so many things. Okay. Let me get rid of this. Let me effect filters, volume, amplify. Oh, okay. I need like the waveform. I don't want the how do I do that? Effect, analyze, tools, no. Is it edit? No. Select. I'm like new to this, so I'm trying to generate effect. I think it isn't right. No. Volume, fade, tempo, equalizer, analyze. Yeah, plot spectrum. This is like where I would be, but I guess we have to do the recording first. So here it goes. Here it goes, I guess. Here goes nothing. So as I said, doesn't really matter positive or negative where it goes, as long as one goes on the temple and one goes on the prefrontal cortex. I think that's what it is. I don't know. I'm tired. One of the frontal cortexes. Alright. Let me do this. Let me do this. And then let me do this. Alright. So now I am relaxed. I'm not doing anything. And then I will now concentrate, or I'll try to concentrate very hard on one thing at 50. So when it comes to 50 seconds, I will try to concentrate. Okay. That was, 20 seconds of concentration. And now back to normal. Well, kind of normal. I was just not doing anything except looking and, try to concentrate. All right. 1 minute and 30 seconds is probably good enough for this test or for this trial. All right. Let's, I don't know, plot, no, find, contrast. I don't know. There was like a cool thing I could do here. Oh, is it waveform? I don't know. How do I move this? Oh, I see. You see these little, like, very small divots? Hold on. How do I... Oh, control? Oh, yeah. You see these very small divots? I'm trying to make them not so small and unrecognizable. Because you can see that there's something going on. But it could just be noise. And I'm trying to make sure that it's not. But I mean, I can definitely say that there was something going on, but who knows what it is? Who knows? Oh, recording level was only at 85%. I'm still not gonna chalk that up to it being like, oh man, why is there's random noise? Trim audio outside, trim audio inside. Envelope tool. How do I get this? Wave color? No. Multiview? No. Spectrogram? I mean, what is that? Actually, that's not bad. I can... Hold on, how do I cut this down? How can I cut this down? Speed... Oh, wait, what? Split? No. I'm trying, okay, there's... Oh, okay, I got it. So because we're... Okay. Some very foggy stuff is going on. Very... Alright, hold on. So I think the main part is from like 30 seconds onwards, because... Alright. Let's see. Oh. I guess let me zoom out a bit. It's very grainy. Like, is there a difference? Like, I can see that there's some high points right here. And right here. And right here. But apart from that, past 30 seconds. Actually, I think there's more high points after 45. I don't know though. I could just be wrong. Can I change the color of this? Hold on. I have oh man, spectrogram settings. Oh, there we go. Spectrogram setting. No? Really? I can't do anything. I can't format. I can't. Well, now I can format, but I can't. Alright, effects, I guess. Add effect. Let's do a... No bass. No bass. I need... Well, yeah, maybe if I do bass boosted, the lower frequencies will show up. But I don't know, I could just be wrong about it. Okay, let's see. So we're getting something. I will say that. Now what it is, I don't know yet. Am I trying to figure out? Yes. Mixer? No. Let's see. Okay. Let me do this. I think that's probably going to be more fun right now. Okay. So now I have that. Can I generate? No, I don't want to generate anything. Effect. Maybe if I do add bass. Oh, maybe if I just add volume in general. Oh, that's quite a bit of volume. To be fair, I boosted it. This is 36 decibels plus 30 decibels. Plot spectrum. Okay, yeah, that's way too much. I need to go back to effect, go back to filters, go back to bass, apply. Okay, go back to effect, back to filters, and then -30, apply. There we go. Alright, back to normal. So I can do that, but also I can plot the spectrum of it normally. Spectrum? No. Okay. I'm just trying to figure out how to put this into like a this thing. Like a sine, just so okay, whatever. Reverb, invert, repeat, reverse. No. Maybe if I just boost the bass then. Nothing happened. Okay, from 200 to 10 hertz. Alright. Should be like... should be the majority of the frequencies. So... or like the majority of the things that we're picking up from the frequencies. Now I do wonder what it is. Like the noise, the sound that it could be. But I also just want to see the difference in no concentration and concentration. And as of right now, I did at like 50 seconds, so this is 50, 55, so 50 is here. And if you were to tell me where did you start concentrating, I would just pick a random point and just say here. Because, I don't know, it's the most dense. But, what else can I say? To be fair, I did say at 1:20, and this is very close to 1:20, I stopped concentrating, so... maybe this and this had some sort of correlation between me starting to concentrate and me stopping concentration. But yet again, could be wrong. I mean, I could try it again with, you know, with all of the settings already in place. So... can I just delete the track? Oh, I can. Alright, that's cool. Alright. Now, round 2. Okay, starting from the top. temple and frontal lobe. I'm not doing anything right now. Well, I was concentrating a little bit, but I'm not really doing anything right now. And right now, I'm not going to look at the time, but I will concentrate in 3, 2, 1. Okay, that's my concentration over. So I don't know exactly when I I wasn't looking, not at the time, I meant at the program. So now that concentration is over, I can see the thing now. So, but when I was concentrating, I couldn't see it. All right. And now well, let's see if it still detects anything if I take it off. Oh, it detects higher noise. Like much, much higher noise. Okay. Alright. Let's turn that off. Let's see. Let's analyze this. So I started... Oh. Okay. I'm guessing I was talking here, and then somewhere either here, or here I started concentrating, and then here or here I finished concentrating. Well, I don't know how long I concentrated for, but these big pillars of just activity, I feel like are a pretty good sign. Can I? Okay, hold on. Yeah, you see, like there's no wave. I want there to be a wave. Effects. Graphic equalizer. Select the audio. Oh, this audio. I forgot where it was again. Amplify. Oh, graphic equalizer. Oh, okay. Yeah, no, not with that. Alright, I just wanted this. Amplify. Alright. Ooh. Amplify at 50. Okay. Alright, there we go. We have some things. Some very boring things, actually. Because... Can I move it back to this? I can. Alright, hold on. Alright. That's back at the start. Now we have... Yeah, okay. So I was right. We have this, which was me putting the, hold on, can I do that? Oh, I can, okay. So we have this random noise, which was me putting on the things on my head. Then we have somewhat normal waves, as you can see, going down, up, whatever, down, up, whatever. Then it's me focusing somewhere. Then it's, kind of peaks, waves here, waves here. Then more waves, more bump, wave. And then, where was it? Me taking it off. I think it was at like a minute and something, like at the end. Oh, here it is. Random noise. Quieted down. So yeah, you have the random noise at the end, looking very close to the random noise at the beginning. Yeah, I think that's how it works. I don't know, it looks very similar. Because this is like flat. You don't see any like wheel, you just see flat. Well, kind of. I mean, you could say all of this is also noise, but you can at least see like waves. I wonder if I can amplify more. That is going to be very noisy, but can I? Let me see. Volume and compression. I can amplify. Oh, wait, I can't. Hold on. See if this will work. Amplify. Apply. Okay. Wow. Very, very grainy. Ooh. Yikes. Let's see. Yeah, it's like... Okay. We have to go into like the milliseconds now. Okay. Sure. So we have waves. Oh, this will be fun gathering all the data for. Because here's the thing. Sure, this thing is very loose, but at least I can say, or at least I can see where there's like dips, where like I'm thinking or talking. But the issue is now, what is it, like machine noise, or is it my brain noise? Which, is kind of an issue. Yeah, because you have like the big dips, big up, big dip again. Yeah, then you have like the wheel, like the saw. I'm still on 8 seconds out of a minute. A minute 30. So let's see. I don't exactly know where I started thinking. I want to know where the random noise is, because Okay, so the saw pattern... Wait, this isn't a saw pattern. This is like a... This is like a Z. I mean a V. But yeah, this is relatively flat. Like looking throughout, this is relatively flat. Well, except for this peak right here and that one. I don't exactly know when I took it off, but I know I did. And I can somewhat see the flat. Oh, here is waves. So it's down, up, down, up, up, down, 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 up. And then this is probably where I took it off. So from 23 to 24 seems about right. Let me zoom out a bit more, because that's probably better. I had like a second. Yeah. Oh, there's so much data to analyze, look through, see what's noise. Oh my goodness. Three times speed. Play. Oh, I can't. Okay. Alright, so I've built it, I've rebuilt it, and it does seem like it works. I'll have to conclusively test this though, because doesn't seem like it wants to work, but it kinda does work. So I don't know. I mean, if you look at things face value, there are very good possibilities that this does work because of the fluctuations when it's connected to the brain and no fluctuations when it's not connected to the brain. But I could be wrong. And also, oh, I can annotate? Oh, I have to... What? I have to zoom in further? Oh, like that? Oh. Oh, that's not annotation. That's just drawing. I didn't know I could see that. Oh, it's just zooming in very, very far. Okay. Wow. Okay, there's no tool for drawing, is there? No, I don't think so. No. Alright, I'm gonna... Yeah, this is like tenths, hundredths of seconds. Wait, 10, 100,000. This is thousandths of seconds. So that's the sample rate we're dealing with. And it's not even going to play because it's too, right? Because if I like zoom out. Okay, hold on. What's wrong? Why does it not want to play? Play, press space? Do I really have to press space? No. So what's wrong? Okay, I'm just confused, I guess. Okay. I guess it doesn't want to play anymore. Alright. Oh, I can amplify it again. Oh, no. Go back. Fade, tempo, equalizer. I mean, I could do another equalizer of just bass. But I could remove the treble. Oh, that makes it a lot better. Why didn't I think of that? Alright, hold on. Let me go back now and see if that has made a difference. Not much. Not much different. Well, I can definitely see like the peaks, the very big peaks, and like the very big lows. But I don't know what's me thinking and what's it being weird. Even though 2.5 years ago I knew this, and because I was studying it, but now I don't. Alright. Oh, wrong thing. This guy? Yes. Okay. Alright. Wow. So, that was pretty interesting, if I were to say so myself. And that's, I mean, that's the best I can describe it. It's still on. Let's see if it's got any hotter. Probably did. No? It did not. Did not get any warmer. Okay. Batteries unplugged. Alright, cool. So now it's, unplugged. So yeah, I mean, that's it. I built it, I tested it, technically it works, but I am biased because I built it just now, or I rebuilt it. So yeah, I mean, hold on, does this work? Nope. Oh, it is nighttime. Alright, I'll see you guys sometime later. I hope you guys have a great night, because it is midnight, past midnight here. So, yeah, I'll see you guys sometime later. I've been streaming quite often now, so maybe I'll do another stream, or maybe I'll do another video. I don't know. But yeah, hope you guys have a great morning, night, afternoon, whenever you're watching this. Have a great day. Peace. See ya.